We are asked to discuss how we know this is a redox reaction using oxidation numbers. This is the reaction occurring. Oxidation number or oxidation state is a theoretical charge we can assign to an atom in a compound if all the bonds in the compound were treated as ionic bonds. It is a way to model or understand how charge is distributed in a compound, and it helps us determine which species is oxidized and which is reduced in a redox reaction. In a redox reaction, the oxidation numbers of two elements change, so we must first assign oxidation numbers to each element in this reaction and then investigate how they change to prove that this is a redox reaction. Let's look at the rules used to assign oxidation numbers. Firstly, an element, whether it is monatomic or diatomic, etc., has a zero oxidation number. Solid magnesium is an element and so has 0 for its oxidation number. And diatomic hydrogen is also an element and so it also has 0 for the oxidation number. Monatomic ions have an oxidation number equal to their charge. Then atoms in a compound, whether the compound is covalent or ionic, have the following oxidation numbers. +1 for the group 1 elements. So hydrogen in hydrochloric acid is +1. Group 2 elements have a +2 oxidation number. So magnesium in magnesium chloride is +2. Group 3 elements are +3. Group 14 elements can be +2 or +4. Group 15 elements have different oxidation numbers, but we have no group 15 elements here. Oxygen in group 16 always has -2 as its oxidation number, except in peroxides. Sulfur can have different oxidation numbers. Group 17 elements have a -1 oxidation number, and so chlorine in hydrochloric acid is -1, and each chlorine in magnesium chloride is -1, so we can write its oxidation number underneath. But there are 2 chlorine atoms in magnesium chloride, and so together they contribute -2, and we can write this above. Transition metals have variable oxidation states. Then oxidation numbers must add up to 0 in a neutral compound. So the 2 compounds in the reaction have oxidation numbers adding up to 0. The last rule is that in a polyatomic ion, the oxidation numbers add up to the charge on the ion, but we have no polyatomic ions here. Now, we have assigned oxidation numbers to each element in this reaction, and we must look at how the oxidation numbers change. Notice that each chlorine still has an oxidation number of -1 even after the reaction. The oxidation number of chlorine has not changed. However, the oxidation number of hydrogen has changed from +1 to 0. Each hydrogen gained an electron, and so hydrogen is reduced. The oxidation number of magnesium has changed from 0 to +2. Magnesium lost electrons, so magnesium is oxidized. Giving the oxidation numbers before and after the reaction for those elements where the oxidation number changed proves that this is a redox reaction.